is my crash course in prime factorization. I just came up with a number to do this with, and I have it on a big piece of paper. I always tell my kids that when they have a large number to do a prime factorization tree of, that it's best to just give yourself a whole sheet of paper and have the space to be able to organize and work it out. So with something like this, you just look for what you can do. Use your divisibility rules. I know immediately by my divisibility rules that this is divisible by 2 because it's an even number. I know it's divisible by 5 because multiples of 5 either end in 5 or 0. I know it's divisible by 10 because it ends in 0. And that's really enough for me. I don't have to check every single divisibility rule. Like, I know this is also divisible by 4 because 80 is divisible by 4, the last 2 digits of the number. You can run through all of those, but I already know that it's divisible by 10, and that's a really easy one, so I'm going to start there. And I just start by that. So I'm going to have 10 on one side, and that leaves me with 3, 6, 2, 8, 8 on the other. So with the 10, I don't have a prime factor there yet, but if I do this, I have 2 prime factors, and I circle those so that I know that that is the end on that side. Now if I come back over here, this is divisible by 2, but it's also divisible by 4, and that's because I know that 44 times 2 is 88. So divisibility rules for 4, if the last 2 digits of the number are divisible by 4, the whole thing is divisible by 4. So I know I'm going to have 4 on one side. And if I look at this, I have a 36 here, so I know that's going to, if I divide that out, which I did by hand, but you know, this is really like one of those places where a calculator is great, because at this age and stage, kids already know how to divide. That's not a skill you're working on. You're just needing some quick numbers, and you know, using a calculator is great for this. So anyways, I'm going to end up with 9, 0, 7, 2 on this side. And I just want to see, I have 9 plus 7, which is 16. And 16 plus 2 is 18, which means this is divisible by 3. And it's also divisible by 2. It's also divisible by 9 because 18 is divisible by 9. So I have a few options here. So how about I do 9 because I can see a really easy division problem there. So if I come over here, I'm going to have 9 on one side, and I see a 90 and I see a 72. So 9 goes into 90 10 times, and it goes into 72. It goes into 72 8 times. So I can just put 108 over here. Okay? Just try to make it as easy as yourself as possible. So over here I have my 4. I end up with a 2 and a 2, and those are my prime factors. So I'm going to circle them, and I know that ends there. I have my 9 here. I'm going to end up with a 3 and a 3, and that's where that ends there. And on my 108, I know from my multiplication facts that, what is it, 9 times 12, oops, is 108, right? And that's just a matter of knowing your multiplication table. That's why it's handy to know. So my 9 becomes a 3 and a 3, like that. And my 12 becomes a 3 and a 4. My 3 is a prime factor. My 4, I'm going to break down to a 2 and a 2, and I'm going to circle those. So now I have the whole thing. So I can go through here, and I have 1, 2, 3, 4, 5. I have 2 to the power of 5. And then I have 1, 2, 3, 4, 5. I have 5 3s, so 3 to the power of 5. And then I have 1 5, and that's your prime factorization of a number like that. I actually picked another number ahead of time just because this one, in my opinion, is so easy to break down because it's so obvious right away, you know, with the rules, like the divisibility rules, like it's just an easy one. But I came up with another number that's a little more challenging. Like let's say you have 1817. If I look at this, I have 1 plus 8 is 9. 9 plus 1 is 10. 10 plus 1 is 7. And so that's 17. 17 isn't divisible by 3. It's not divisible by 9. So we can rule that out. The last two digits being 17 are not divisible by 4, which means 4 isn't going to work. The last digit is not an even number, which means it's not divisible by 2. It doesn't end in a 0 or a 5, so it's not divisible by 5. It's also not divisible by 10. So this one starts to get a little trickier. So what I do at that point is I look at this 7 and I think to myself, well, what numbers multiply together to give you a 7 in the ones place? So when I think, like, if I think about 2's, well, actually, let me start with 1. 1 times what will equal 7? So anything that has a 1 in the ones digit and a 7 in the ones digit is going to equal 7 like this one does. Meaning, like if I multiply 111 times 27, I'm going to have a 7 in the ones digit. Okay? So if I think of my 2's, there's nothing where I'm going to have a 7 in the ones digit multiplying by 2, so I'm not even going to think about that. If I think about 3's, I know that 3 times 9 equals 27, and I think pretty sure that's the only one. Okay, 4's, there's nothing that's going to work to give you a 7 in the ones place. There's nothing for 5's or 6. 7 we already have because we have it here. 8's, 9's, like if you go on, there is nothing else. We go back to the beginning. These are the only combinations that will get you a 7 in the ones place. So I have to start thinking about prime numbers that have either a combination of a 1 and a 7 or a combination of a 3 and a 9. So what you'll want to do is start dividing 1817 by different numbers that will have this combination. For example, like 11 times 17. See what you get. 21 is not a prime number, so I'm not going to use that one, but let's say 31 times, what's another prime number with 7? Well, you could do 31 times 17. You're going to have to try that out. You're going to have to try dividing this number by some of these primes to see what works. Okay, so when I start fiddling with these numbers, looking for any prime numbers that have a 3 and a 9, or, well, it really doesn't matter because you're just dividing by one of these. So dividing by primes that have a 3 in the ones place, or a 9 in the ones place, or a 1 in the ones place, or a 7 in the ones place. And, you know, if you start from the bottom and you work your way up, like your first prime that you're going to mess with that has that is 11. And then there, you know, 13 is a prime that falls into that rule. And then 17 is a prime that falls into that rule. And then 23 is the next one. So really, I've tried 4 digits and 23 does work. So I end up with 23 and 79. When I divide 1817 by 23, I get this number. And because I know that's a prime, that's it. That's as far as you can go. But I guess my point is that when the divisibility rules, you know, for larger numbers don't work, when you have a number like this where you're like, well, none of these work, then this is my other go-to trick, is just looking at that ones, the number in the ones place, and starting to look at prime numbers that end in whatever that number is, like, you know, combinations that will give you that number, and just testing them out until I get something. And you know, I wouldn't have your kid handwrite that. That's a lot of work. They should already know division by now. So it's really just a matter of running through some numbers and testing them out. But I actually don't remember any of the combinations being this way in pre-algebra. I think they were all pretty straightforward.